Hello and welcome to my presentation about microservices with Wildfly-Swarm. My name is Julian and I will give a short introduction into microservices and then start straight away with the live coding. So, why do we need microservices? Before microservices, we had the monolithic architecture with all its disadvantages. One of them is, for instance, that new developers need a long training period to get an overview of the project as it's a vast application. Also, code won't be improved often because no one can estimate the side effects of the optimization that can occur. But the biggest disadvantage is that if one component of the application breaks, the whole application is down. This leads to a big loss of sales. Therefore, a new technology has been developed called microservices. They are completely segregated services and that's why they are associated with the keyword resilience. If one of the services goes offline, the other services are still accessible and working. Other advantages are that developers are now more enthusiastic to optimize the code and use new technologies as the projects are smaller and the side effects can be estimated much better. Also, the training period takes only a fraction of the time that is needed for monolithic architectures. The project that I will show you today is built with Wildfly-Swarm. Further details are explained during the live coding. Alternatives regarding the Wildfly-Swarm would be the Payara Micro and Spring Boot. Further details are also explained during the live coding. So this was the introduction, and now we are going to build a microservice with a JAVAEE Backend and an Angular plus HTML frontend. Our data will be persisted in a H2 database server, and after that I will show you a small online shop application to demonstrate the resilience of microservices. So first of all, we need to create a new application. We choose Maven and then we type in the group ID and the artifact ID. Then we click Enable Auto Import. So what I've done now is to build the POM file, and now I will explain the details. Wildfly-Swarm packs the application along with the application server into one single jar file called a fat jar. All libraries are provided by Wildfly-Swarm via Maven Central. For instance, if we don't need the GPA dependency, we just leave it out. Under the build section, there is the Wildfly-Swarm plugin. So what this plugin does is that it creates the runnable jar file for us. You can also configure your swarm by adding a class in the configuration tag. We will take a closer look at this later on. The next thing we need to add is the persistence XML. Under project settings and facets, we add JPA. Then we add the persistence XML. Now we edit the directory structure to the Maven directory structure. And then we need to change the version from 2.0 to 2.1. As you can see here, we take the value update to create the database if it doesn't exist, and if the database already exists, we just leave it as it is. Then we add the configuration class we talked earlier about. In the configuration class, we start the H2 database server on the port 8081 and add a data source to the Wildfly-Swarm with the connection details of the database server. Here we can see Swarm Fraction. Fractions are composable pieces which enable you to add features to the Wildfly-Swarm. So the next thing we need to do is to implement the entities. First we start with the address entity. So what we have here is a normal entity with JPA annotations, the fields, an empty constructor, a constructor with parameters, and the getters and setters. The next thing we are going to add is the customer entity. Note that on this entity we also have a named query called customer find all to retrieve all customers from the database. In order to communicate with the microservice, we need to implement a REST service. Therefore, we implement the REST config class. Be sure to select the right package. The next thing we need to add is the init bin class. But what is the purpose of this class? Well, if the database is empty, we insert some test customers. On the bottom, we also start a new browser window which is pointing to our frontend, which we will implement later on. To avoid problems that could occur between multiple microservices that are communicating with each other, we need to implement a coarse filter right now. But when does coarse occur? Well, if the browser retrieves data from a domain such as an order microservice, and this microservice retrieves data from the customer microservice, then coarse occurs. Because resources are accessed that are from a different domain than the other resources. Therefore, the coarse filter adds headers like the access control allow origin header, which tells the browser that the resources from this domain are accessible for other domains just as the order microservice. Now we need to add a resource class which implements a get and a put call on the customer entity. We just name it customer resource. We will need this class later on in order to retrieve all customers and to update certain customers. By now, we have finished creating the JAVAEE Backend for our service. Now we need to add the frontend using HTML and AngularJS. We want to show the customers in a table using Bootstrap as a CSS framework and AngularJS to edit the data. We just click on the web app folder and add a new HTML file called index.html. As you can see, I include the Bootstrap CDN here. Then I render a table showing the customer data, and with AngularJS I'm able to edit this data. On the bottom I include some scripts for the AngularJS configuration. What is still missing is the configuration for AngularJS. First, we need the app. We click on the web app folder and add a new JavaScript file called app.js. Then we create a new Angular module. Then we need to implement the controller which holds the data for us and accesses the data service. We click on the web app folder again and add a new JavaScript file called controller.js. As you can see here, the controller is called main controller and it holds the data for us, such as the customers. It also accesses the data service with its functions, just as get customers or update customer. Last but not least, we need to implement the data service, which gathers the data from our previously added JAVAEE Backend. We click on the web app folder again and add the last JavaScript file called dataservice.js. As you can see here, the data service accesses the local host on port 8080 on which our REST service is located. We implement the functions get customers and update customer. The last thing we need to add is the start configuration. We just click on edit configurations and add Maven. In the command line text field we write Wildfly-Swarm run. Then we can just click the run button. What will happen if we click it? Well, the plugin will generate the FATJA for us and continues with starting it. Now to Payara Micro and Spring Boot. Spring Boot also generates a FATJA just as Wildfly-Swarm, but generates a standalone Spring application. Payara Micro is a bit different. It creates a WAR file of about 1 MB. With the Payara Micro jar, which can be downloaded from the website, you can deploy this WAR file. I read a funny punchline about 1 week ago which said, "Make jar, not war," which I found really hilarious. This punchline probably came from the Wildfly-Swarm community. So, let's talk about the application. What happened is that the application opened a new browser window which shows the customer data in this table. By clicking the edit button, we can simply edit the customer data. By clicking the save button, the value is updated via the REST service and therefore gets also updated in the H2 database server. Now I want to show you a small online shop example that consists of 3 microservices: the product, customer and commission service. As you can see, each microservice has its own database and they are completely segregated and only communicate via REST. The commission service loads customer data and product data from the other services via REST. Let's take a closer look at that. The only thing I need to do in order to start these services is to run the generated FATJA on the command line. I will type java -jar and then the dedicated jar file. Product -swarm.jar. the customer microservice and the product microservice work without limitations if one of the other services is going down. For instance, if the product service goes offline, I can still edit the customer data without restriction. I will now kill the product microservice, and as you can see, the service is offline. When I refresh the customer microservice, the data is still there and I can still make changes to the data. However, the commission microservice lacks the data for the product. This is because the product service can't be reached. But still we can see who placed an order, how it was paid and how it is going to be delivered. And also we can still edit this data which represents the resilience of microservices. For example, I changed the shipment type to standard or the payment type to credit card. As soon as the product service goes back online, we can see the products too. I will start the product service again. Now the product service is back online. If I refresh the data, the products are there. The same applies to the customer microservice. If it is going down, we can still use the product microservice without limitations, and on the commission service we miss the first and last name of the customer. But still we can edit data and get information about which order was placed when, how it was paid and how it will be delivered. So this was a short introduction into building microservices with Wildfly-Swarm, and I hope you enjoyed it. Have a nice day.